Yes, in a panel located in a non-service situation where all the loads are considered continuous, the main breaker is required to be sized at a minimum of 125% of the total continuous loads. This requirement is crucial for ensuring the safe and reliable operation of the electrical system. A continuous load is defined as a load where the maximum current is expected to continue for 3 hours or more. The National Electrical Code, or NEC, mandates this 125% rule to prevent the main breaker from tripping due to prolonged high current draw, which could lead to overheating and potential fire hazards. To properly size the main breaker, firstly, calculate the total continuous load by adding up all the individual continuous loads connected to the panel. Secondly, multiply this total continuous load by 1.25, which is equivalent to 125%. The resulting value is the minimum ampacity required for the main breaker. Thirdly, select a standard breaker size that is equal to or greater than this calculated value. It is important to note that breakers are available in standard sizes such as 15 amps, 20 amps, 30 amps, 40 amps, 50 amps, 60 amps, 70 amps, 80 amps, 90 amps, 100 amps, 110 amps, 125 amps, 150 amps, 175 amps, 200 amps, 225 amps, 250 amps, 300 amps, 350 amps, 400 amps, 450 amps, 500 amps, 600 amps, 700 amps, 800 amps, 1000 amps, 1200 amps, 1600 amps, 2000 amps, 2500 amps, 3000 amps, 4000 amps, 5000 amps, and 6000 amps. Always round up to the next available standard size if the calculated ampacity falls between two standard sizes. For example, if the total continuous load is 80 amps, then multiplying by 1.25 results in 100 amps. Therefore, the main breaker should be rated at least 100 amps. Moreover, the overcurrent protection device, which is typically a breaker or a fuse, must be sized to protect the conductors feeding the load. The conductor ampacity must be sufficient to carry the calculated load current. According to NEC section 210.19, A1, branch circuit conductors shall have an ampacity not less than the maximum load to be served. For continuous loads, the conductors must be sized to carry at least 125% of the continuous load as specified in NEC section 210.19. A1 exception number 1. This ensures that the conductors will not overheat when carrying the continuous load current. In addition to the main breaker and conductor sizing, it is also important to consider the panel board's ampacity rating. The panel board must be rated to handle the total load connected to it, including both continuous and non-continuous loads. The panel board's rating should be equal to or greater than the sum of all the breaker ampacities. When dealing with non-service panels, it is common to have multiple branch circuits feeding various continuous loads. Each of these branch circuits must also adhere to the 125% rule for continuous loads. The branch circuit breakers must be sized at a minimum of 125% of the continuous load they serve. For instance, if a branch circuit feeds a continuous load of 16 amps, the breaker must be rated at least 20 amps because 16 amps multiplied by 1.25 equals 20 amps. It's crucial to ensure that the wiring and components used in the electrical system are suitable for the calculated load and environmental conditions. Factors such as ambient temperature, conductor insulation type, and derating factors must be taken into account when determining the conductor ampacity. The NEC provides tables and guidelines for adjusting conductor ampacity based on these factors. For example, NEC Table 310.15. The 16 provides ampacity ratings for various conductor sizes and insulation types at different temperatures. If the ambient temperature is higher than the temperature rating of the conductor insulation, the conductor ampacity must be derated accordingly. Furthermore, if multiple conductors are bundled together in a conduit or cable, the conductor ampacity must be derated to account for the increased heat generated by the conductors. NEC Table 310.15. B3. It provides adjustment factors for the number of current carrying conductors in a raceway or cable. It is also essential to ensure that all electrical connections are properly made and tightened. Loose connections can cause excessive heat and arcing, which can lead to equipment failure and fire hazards. Regularly inspect electrical panels and connections to identify and address any potential issues. Use appropriate torque specifications when tightening connections, and use approved connectors and terminations for the conductor sizes being used. Understanding the difference between continuous and non-continuous loads is paramount. A non-continuous load is one where the maximum current is not expected to continue for 3 hours or more. For non-continuous loads, the breaker and conductor sizing requirements are different. According to the NEC, the breaker and conductors must be sized to carry at least 100% of the non-continuous load. However, it is often recommended to provide some additional capacity for future load growth or to account for voltage drop. In summary, when dealing with continuous loads in a non-service panel, the main breaker must be sized at a minimum of 125% of the total continuous loads. This ensures that the breaker will not trip due to prolonged high current draw, and it helps to prevent overheating and fire hazards. Additionally, the branch circuit breakers and conductors must also be sized to accommodate the continuous loads they serve. By following these guidelines and adhering to the NEC requirements, you can ensure the safe and reliable operation of the electrical system. Always consult with a qualified electrician to ensure that the electrical system is properly designed and installed in accordance with all applicable codes and regulations. Correct breaker sizing is a fundamental aspect of electrical safety, preventing overloads and potential hazards. Regular inspections and maintenance are crucial to maintaining a safe and efficient electrical system. Remember, electrical work can be dangerous and should only be performed by qualified individuals who have the necessary training and experience. Always energize the circuit before working on any electrical components, and use appropriate personal protective equipment such as insulated gloves and safety glasses. By following these safety precautions, you can minimize the risk of electrical shock and other hazards. The 125% rule is a cornerstone of electrical safety for continuous loads, and its proper application is vital for ensuring the longevity and reliability of electrical systems. Neglecting this rule can lead to premature equipment failure, increased energy consumption, and potentially dangerous conditions. In addition to the breaker and conductor sizing requirements, it is also important to consider the voltage drop in the electrical system. Voltage drop occurs when the voltage at the load is less than the voltage at the source due to the resistance of the conductors. Excessive voltage drop can cause equipment to operate inefficiently or even fail. The NEC recommends limiting the voltage drop in branch circuits to 3% and the voltage drop in feeders to 5%. To minimize voltage drop, use larger conductor sizes or shorten the length of the conductors. The 125% rule does not apply to motor loads. Motor loads have specific requirements outlined in NEC Article 430. The overcurrent protection for motor circuits must be sized based on the motor's full load current rating and the motor's design characteristics. It's important to differentiate between the requirements for continuous loads and motor loads to ensure proper protection of the electrical system. Furthermore, understanding the specific definitions and requirements outlined in the NEC is paramount for compliance and safety. The NEC is a comprehensive document that provides detailed guidance on all aspects of electrical installations. It is regularly updated to reflect the latest technological advancements and safety standards. Staying informed about the latest NEC requirements is essential for anyone involved in electrical work. Incorrect breaker sizing can lead to a variety of problems, including nuisance tripping, equipment damage, and fire hazards. Nuisance tripping occurs when a breaker trips unnecessarily due to minor overloads or inrush currents. This can be disruptive and inconvenient, and it can also indicate a more serious problem with the electrical system. Equipment damage can occur when breakers are undersized, allowing excessive current to flow through the conductors and components. This can cause overheating and premature failure of the equipment. Fire hazards can arise when breakers are oversized, failing to trip in response to a fault condition. This can allow excessive current to flow through the conductors, causing them to overheat and potentially ignite surrounding materials. Therefore, ensuring the correct breaker sizing is essential for preventing these problems and maintaining a safe and reliable electrical system. Regular maintenance and testing of electrical panels and breakers are also crucial for identifying and addressing any potential issues before they escalate. This includes inspecting the breakers for signs of damage or corrosion, testing the breakers to ensure they trip at the correct current levels, and tightening any loose connections. A qualified electrician can perform these tasks and provide recommendations for maintaining the electrical system in optimal condition. In addition to the technical aspects of breaker sizing, it is also important to consider the administrative and regulatory requirements. Electrical installations must comply with all applicable codes and regulations, which may vary depending on the location. Obtaining the necessary permits and inspections is essential for ensuring that the electrical work is performed safely and in accordance with the applicable standards. Working with a licensed and insured electrical contractor can help to ensure compliance with these requirements. The concepts discussed relate to many facets of electrical engineering. Consider how power distribution is impacted and how large buildings can be wired safely. These considerations become very important when designing large-scale projects.